Okay, so let's go on page 68 when we're done. This is the Pythagorean theorem and its converse, but just because it's the Pythagorean theorem and I know it is not brand new to you, doesn't mean you can tune me out and you know all this because you don't know all this. First of all, what is the Pythagorean theorem? John, a squared plus b squared. Okay, that's what most of y'all would say, right? Okay, but it's not that it's wrong. It's that there's actually words that go with it. Like that in itself is not that doesn't really mean anything. Those are just letters. The Pythagorean theorem says, because it's a theorem and there's words, in a right triangle, because it only works for a right triangle, the sum of the squares of the lengths of the legs equals the square of the length of the hypotenuse. Okay, so the sum of the squares means you square the leg lengths, then you add them. It's equal to the length of the hypotenuse squared, which in a sense does give you a squared plus b squared equals c squared. But again, those are just random letters that are squared and put together if there's not any words to go with it to make it make sense. Okay, we good? So it's not like it's wrong or you haven't learned it right or whatever, but you need to know that there are words to go with it. It is called the Pythagorean theorem because a guy named Pythagoras is the one that touted this the most. They're not things that are named after people. It's not always because that person was the first to develop it. It's usually just it's the first one that tweeted it out and got credit for it, right? It's the ones that are, given the credit for it or took the credit for it. But Pythagoras was a wacky dude. He had kind of a cult following, and he met an untimely death, and it's just like they could make a mini-series out of his life or something. I'm kind of surprised they haven't, because it was pretty dramatic. But we'll talk a little bit more about him next week, and I'm going to show you something that kind of tells you about some of those weird things about him. And then, so when you label these, notice that these are lowercase a, b, and c, right? Because they're side links. They represent numbers. We talked about that when we were looking at points, lines, and planes. But this lowercase c here, this side is across from the right angle, which would mean if this is lowercase c, this point is a capital C. This is my lowercase a, so the angle across from it is your capital A. And then here's the lowercase b, so this is b. Okay. So c is always what we use for the hypotenuse. How do you identify the hypotenuse? Michael? It's across from the right angle. Very good. Now, something else that's true about it is that it's the longest side, but that's not how you really identify what it is. It's the one that is across from the right angle. Very good. All right, so we're going to use the Pythagorean theorem. Now, a couple of little things that you've got to make sure that you do, which you may not have been required to do in the past, is that all three parts, A, B, and C, all get replaced every time. Never leave an A, B, or a C in there. It gets replaced with a variable or something. Okay, so if we're going to find the value of x here, this is a right triangle looking for a missing side. So a squared plus b squared equals c squared. In this case here, which one is c? X. Okay, which one is a? Doesn't matter. Well, it does matter because it can't be x, but it's either 6 or 4, right? Yeah, I know what you meant. But all right, so we'll just use 6. That's fine. So 6 squared plus 4 squared equals x squared. First step, 0 work, plug it in. Substitute it in. Do not square it as you write it down. You substitute it in, then you move forward. So this gives me 36 plus 16 equals x squared. So what's 36 plus 16? 52. So x is equal to the square root of 52. Do I grab my calculator? No, you don't even have one to grab. Do I leave it like this? No, I try to simplify it if I can. What are two numbers that multiply to give me 52? Okay, 2 and 26. I heard in 26 and 2. So this is a prime number, and then this becomes what? 13 and 2, and those are both prime numbers, which means in the end x equals 2 times the square root of 13. Okay, we good? Any questions? Okay. All right, so then let's look at B. On B over here, which one would represent C? X. So that means I could have 5 squared plus x minus 1 squared equals x squared. Does what have to be in parentheses? X minus 1. Does it? Yes, because otherwise all I'm saying right here is that I'm squaring at 1. Does that make sense? So yes, this absolutely does. Thank you. Okay, so go ahead. I'm going to give you a minute or so to work this one out. Okay, so is anything weird happening for any of you? All right. Well, x minus 1 squared, does that equal x squared plus 1? It absolutely does not. Okay? I didn't ask what it was. I asked, is it this? And the answer to that is no. Anytime you square anything, it's the same as doing what? Multiplying it by itself. So x minus 1 squared is x minus 1 times x minus 1. You don't just get to square the first ones and square the second ones. You do not distribute that squared sign. It does not work that way. Okay, those are two terms there. If they were multiplied together in there, then you have the power of a product rule. That's why it's called power of a product. That's not a product. This is a difference or a sum if it was being added. So at this point then, you either FOIL, you do the box, you do distribution, you do whatever it is that you learned and that makes sense to you, but it is not x squared plus 1. When you multiply it out, the 5 squared is 25, and then you should get x squared minus 2x plus 1 equals x squared. If you have absolutely no idea where that came from, then you need to spend quite a bit of time on Khan Academy this weekend because that is a review. Okay, so now when I get to this point, what kind of equation does this look like it's going to be? A what? A quadratic. Okay, it looks like a quadratic. So if it's a quadratic, I got to set everything, I got it set equal to 0, so I'm going to subtract x squared from both sides. When I do that, these cancel out and these cancel out. So is it actually a quadratic? No. So I'm left with 25 minus 2x plus 1. So then I just start moving stuff around. Equals 0. Do not lose the sight of the fact that you have an equation, right? Because this is what some of you do. Like that goes away, so now you just have this. So now I would see people add 2 to both sides. Both sides of what? I don't know. But that's when you just start making stuff up. There is no equation. Therefore, you can't do anything else until you fix that. So I saw my equal sign. If there's nothing there, you put something that represents nothing. 0, right? Then you can move things around because now you have something to actually do on either side of. So I would add 2x and get 26 equals 2x. So x equals 13. Okay, we good? Any questions? Alrighty. Next page. Oh no, not next page. Is there something wrong? Oh yeah. All right, so our definition. This definition is of a Pythagorean triple. So a Pythagorean triple is a set of 3, hence the word triple, 3 non-zero whole numbers. Okay, there was like tons of confusion about what non-zero whole number was, third period. Non-zero means it's any number that's not what? 0. Good job. Okay, so a non-zero number is a number that's not 0. I don't know how else to explain that. Whole number means it's the whole thing, right? There's no fraction, there's no decimal. It's a whole number, not a partial number, right? So a non-zero whole number, the numbers you get to use to count, right? So a, b, and c such that a squared plus b squared equals c squared. So what it's saying is that obviously we don't always get whole numbers because we didn't in that that first example that we had, right? We got a square root in there. So that wouldn't be a Pythagorean triple. But here, I have these numbers, this is just examples of some of the sets, that if I put them in the Pythagorean theorem, a squared plus b squared does equal c squared. It is not really necessary to memorize them. I have had students in the past that said that they've had teachers that made them memorize. Any of y'all have to memorize these or even ever heard of these? Okay. It's really not necessary because once you do this stuff enough, you start to recognize some, and then once you recognize them, if you know a few, that's great, and you can use them, and you should learn to recognize them. Should you go home and try and memorize all the sets? No, that is a complete waste of your time. Because if something is a Pythagorean triple, and you end up doing the Pythagorean theorem, it ends up working out very nicely, and it's no big deal. It's almost faster and easier just to do it than to worry about trying to memorize them. But you do need to be able to recognize them and know what they are. So, for instance, this 3, 4, 5. If I have a right triangle, and if this is 3 and this is 4, then if I do Pythagorean theorem, what I'm going to get is 5 for the hypotenuse. So that's what it means by a 3, 4, 5 triangle. Does that make sense? And I could do 5, 12, 13, and 8, 15, 17, and so forth. Then 3, 4, 5, and 5, 12, 13 are the ones that you're going to see and recognize the most. But if I have, what was the other one I wanted to use? Okay. 8, 6, and 10. Now that's not in a list, and it'll probably never be in a list of Pythagorean triples for you. But what you have here is 2 times 4, 2 times 3, and 2 times 5. Where you still have a 3, 4, 5 triangle, and all of those are being multiplied by the same number. So these two triangles are what? Similar to each other. Yes, sir. Mm-hmm. Why not? It has to be greater than, so it works. Yeah, no, it is. So this right here, any multiple of the 3, 4, 5, as long as they're all multiplied by the same number, keeping the triangle similar, this is what I would call a 3, 4, 5 in disguise. Does that make sense to you? And so as a 3, 4, 5, you'd recognize a 6, 8, 10, which means if you know that this is 3 and this is 4, this has to be 5, and you don't really have to do any work. Okay? Mm-hmm. Absolutely. Yeah, because that would be, as long as all three of them got multiplied by 10, so you get 30, 40, 50, it works the same. All right, good question. That's what I just said. Yes, and that's why you want to, that's why it's good to start recognizing them, so that you can do that, but you have to be careful. Don't spend any time trying to, unless you're asked if it's a triple, don't spend any time trying to figure out what it is when you could have just worked the problem and been done with it. Does that make sense? I mean, if you recognize it, you can see that, then yes, you can do that kind of stuff. And that's one of those things, like even on the AP test, it's one of those that if there's no work shown, it's okay because it's a triple and because there's this pattern here and that sort of thing, and it's fine. Okay, we good? But there's some obscure ones that don't show up much that you might not recognize until you do it, and then when you're done, you go, oh, that's a triple. And that's okay, then you just move on, it's all fine. Okay, we good? Okay, so let's look at the next part. This says, find the missing side length, tell if the side lengths form a Pythagorean triple. All right, so here I have this, and I'm going to call this x, so I have something to call it. So x squared plus 12 squared equals 15 squared. So x squared, what's 12 squared? 144. What's 15 squared? 225. Okay, remember you need to know your perfect squares up to 25. So then x squared equals what? Let's do this. Don't ever, no, anybody else say the answer. What's 225 minus 100? 125, right? So then 125 minus 40, I can subtract 20 to get to 100, and 20 more, I'm at 85, right? And then minus 4 gives me 81. Okay? See how you can do it in stages? Yes. Yes, but you need to learn to P in a different class. Okay. So then x equals what? 9. So x equals 9. So we found our missing side. So is this a Pythagorean triple? Yes. The answer is yes. And what we have here is 3 times 3, 3 times 4, 3 times 5. So this is a 3, 4, 5 also. Okay? And it's okay if you don't recognize them. I mean, it is okay. 3, 4, 5, quickly you should start to recognize those. But the ones in disguise, if you don't necessarily notice it, it's okay. So if somebody else just sees that, and you know, some of us have those kind of brains where if I said go home and memorize all the triples, it'd be like a piece of cake for you. You'd come back tomorrow, you could rattle them all off, and everybody would give you dirty looks, right? But those are like few and far between. But there are people whose brains work like that, and that's great. That's great for you. But that's not for everybody. And so some people will start to recognize them quicker than others, and that's okay. Right? Don't stress yourself out over it. But again, you need to recognize them. You need to be able to find it and know what it is, even if you don't know them off the top of your head. All right, so then here, we'll call this one y. So we have something to call it. Now, this is 3 times 3, and this is 3 times 5. So would this be 12? No. How do I know for sure it's not? Because it's the hypotenuse, so it has to be the longest side. Like, I identify it that it's across from the right angle, but I also know it has to be the longest side. So what you have to be careful with in this identifying process and just knowing everything's a Pythagorean triple is that sometimes you'll get something where this is 3 and this is 5. And so you're like, oh, it's 3, 4, 5. You put a 4 on that and you move on, and that makes absolutely no sense, right? So make sure they're out actually in the right places before you start to try and apply it to everything. All right, so then I'm going to do 9 squared plus 15 squared equals y squared. 9 squared is what? 81 plus 225, and that's equal to y squared. So y squared equals 306. Is that a perfect square? No. And even if it was, and maybe you didn't know it, or you thought it was, but you weren't sure what it was, it's just like if you have a fraction and you start reducing the fraction and you reduce it all and you actually get a whole number, that means it was actually divisible by that. You just didn't realize it. You just treated it like reducing a fraction. Same thing here. Even if it's a perfect square and you don't know it, if you do the tree, it still works. But once you take everything out and nothing's left inside, that just meant it was a perfect square. Does that make sense to you? So sometimes that might happen to you. So we get y equals square root of 306. Now, I'm guessing that numbers probably don't just like jump out at you like big numbers anyway, but it's even and it's divisible by what? 3, okay? And 6. But so we'll start with 3. Yes, sir. Okay. All right, so we'll start with 3. And you can start with something else. It's fine. We'll talk about something else when we're done. 3 and then what? 102. Is that one also divisible by 3? Yes. And so 3, and then 3 goes into 10 3 times with 1 left over, so 34. And then is that divisible by 3? No, but it is divisible by 2, and then I get 17. Okay, so the 3 trick where you add the digits and see if it's divisible by 3 works for 9 also. If you add the digits and what you get is divisible by 9, then the number is divisible by 9. So we could have started with 9, we'd end up splitting it up anyway. Or 6. If it's divisible by 3 and 2, then it's divisible by 6. Like, there's other ways to look at that. Okay, so in the end, then, I get that y equals 3 square root of 34. And then, is this, then, a Pythagorean triple? No, because this is not a whole number. It's non-zero, but it's not a whole number, so this is a no to the Pythagorean triple part. Any questions? We all good? Okay. Example 3. Brad is building a rectangular picture frame. He wants the ratio of the length to the width to be 3 to 1, and the diagonal to be 12 centimeters. How wide should the frame be? Okay, so we're going to start by drawing our picture. Here's a rectangle. I know that I want the diagonal to be 12 centimeters, and it's a rectangle, so these are right angles. Now it gives me a ratio of the length to the width. So what did I tell you to do with the ratios? Add an x. So if the ratio of the sides is 3 to 1, then I can use the sides as 3x and 1x. So the length can be 3x, and the width can be 1x, or just x. Oh, God, please don't break. I keep dropping the pins, and then they don't work. I'm going to cry. Oh, shit. God. I'm going to drop the pin again. They're going to stop giving me pins. And I don't know where my other one is. Oh, well, joke's on y'all. Now I'm going to have to use a document camera, and that's not good. So, haha, joke's on you. I don't know where my other pin is. Goodness gracious. Okay. I don't have another pen. I'm going to cry. Okay. Hang on. Yeah, I'm going to. All right, here we go. So my length and my width are 3x and x. So this is 3x. This is x. All right, so I want to know how wide the frame should be. So basically I'm looking for x, right? This is a rectangle, but there's a right triangle in there, so I can do Pythagorean theorem. Yes? Okay. So I'm going to use, there are 2 right triangles. Good. So I'm going to use 3x squared plus x squared equals 12 squared. Now, did I write all this down right? Does 3x have to be in parentheses? Yes, no, yes. Yes, because this right here, which is what most of y'all would just write down, is just squaring the x. But I got to square the whole side length, so this absolutely has to be in parentheses, and it means something completely different. Okay? So this means I multiply 3x times 3x, which gives me what? 9x squared. Plus x squared equals what? 144. So this gives me 10x squared equals 144. So can I take the square root of both sides here? No, because I don't have x by itself. So x squared is equal to 144 over 10. Can I reduce that? Yes, that reduces to? What are these both divisible by? 72 over 5. Okay. Can I reduce that anymore? No. Okay, so that is equal to x squared, which means that x equals the square root of 72 over 5. Now, if you actually went and watched that radical video that I told y'all to, and 98% of you did not, then you would know that this is the square root of 72 over the square root of 5. Are either one of those perfect squares?
Oh, no, I lied.
I don't think the 5 is. Well, don't be a follower and you won't do that. Okay. But can I simplify the square root of 72? Yes. So square root of 72, this becomes 2 and what? 36. Okay. So do I have to go any farther then? No. Can I simplify the 5 at all? No. So this gives me it gives me 6 square root of 2 over what? Square root of 5. Okay. And that represents x, and so that means that that is the width that I am looking for. There is nothing else you can do at this point to simplify it, but here's what you need to know, is that this right here with the square root in the denominator is illegal. So this is not legal. You are not allowed to leave a square root in the denominator. However, you do not have the skills to get it out of the denominator just yet. We're going to talk about that on Monday. So for this assignment and this assignment only, you are leaving the square root in the denominator. Okay? Because right now I'm just concerned with you getting, being able to handle weird looking answers and being able to get to that point. We'll worry about what to do with that later. Stop it. Okay, so I'm just telling you that it's not legal. On Monday, I'm going to show you what to do with the square root in the denominator, but you are not going to have to come back and fix it on this homework. Does that make sense? Like, I want you to leave it like that. And I know that this just asks you for the width, but we're also going to look at the length here because I want to make sure that you know how to deal with weird-looking stuff like this. What am I doing? Length is what I'm writing legal again. Length. So the length, then, is 3x, right? That's what it's represented by. So that is 3 times, I just found x, which is 6 square root of 2 over the square root of 5. Now, when I multiply a whole number times a fraction, what do I do with the whole number? I put it over 1, right? And then I just multiply straight across. So what is 3 times 6 square root of 2? 18 square root of 2. You treat your square roots like variables, so that's just like 3 times 6x would be 18x. So this is 18 times the square root of 2. What do I get on the denominator? Square root of 5, right? And this is the length, so I don't have to write it again. And again, this right here is also not legal because there's a square root in the denominator, but it's okay for now. Okay? You have permission on this assignment and this assignment only to break the law. Yes? 3 times x equals 3 times x. I substituted it in. Okay, we good? Any questions? So, yeah, this looks weird. It's going to push you out of your comfort zone, but you're going to have to get over that real quick because there's going to be a whole lot of stuff that looks a lot weirder than this. Okay? We good? All right, next part. So now we're going to look at the converse of the Pythagorean theorem. So the Pythagorean theorem says, if you have a right triangle, then a squared plus b squared equals c squared, basically. The converse says, if a squared plus b squared equals c squared, then it's a right triangle. So that's it in a gist here. So this says, if the sum of the squares of the lengths of the two sides of a triangle is equal to the square of the length of the third side, then the triangle is a right triangle. So if you just look at this picture, there's nothing here that tells you that this is a right triangle. Looks like it, but that doesn't really mean anything, right? So if you have this, and then you take the three side lengths, you plug them into the Pythagorean theorem and see if you get a true statement. And then you just would pick, that's when you would pick the longest one to represent C, and then if it works, then you have a right triangle. Okay, so if you want to test it, you substitute it into there and see if what you get is a true statement. So if you get that a squared plus b squared does equal c squared, then triangle ABC is a right triangle. Okay, we good? So then we have Pythagorean inequalities, which I put them on here how they're actually given to you, but we're going to change them because this is the actual rule, but it's better for you to understand them in a different way. Because these are written with c squared first, and you've probably never in your life said, well, the Pythagorean theorem is c squared equals a squared plus b squared, right? That's just not what comes natural. It's not wrong because it's still the same thing. It's just not how it's going to progress in your brain most likely. There is a reason that they are like this, but it's not that big of a deal. It's actually better if you're consistent. So the problem is, though, these are inequalities, so you got to make sure that we flip the whole thing around. So if I want to put the a squared plus b squared first, then I also have to reverse the inequality sign, so I have to say that that's less than c squared, and then we're going to mark that one out. Then same thing here, we're going to do a squared plus b squared, and that would be greater than c squared. Does everybody understand what I did? I just took them and flipped them around. I left them on there like that, though, because if you were ever to look them up or whatever, that's what you would actually see. So I want you to think about this. So I have this right triangle right here, right? So I have this right triangle. Right now, since this is a right triangle, a squared plus b squared equals c squared, right? If I was to extend this side and make that side longer, then it's no longer a right triangle, right? And the more I open it up, and I can't really open it up anymore, then the bigger this angle gets, right? So now, since this side is getting longer, c squared is getting bigger and bigger, right? So now a squared plus b squared is going to have to be less than c squared because this keeps getting bigger, and this angle gets bigger too, so what kind of triangle is it? Obtuse. So if a squared plus b squared is less than c squared, then it's an obtuse triangle. If I have a right triangle, and then I shrink this side, then now a squared plus b squared equals c squared, but as I shrink this, now a squared plus b squared is going to be greater than c squared since c squared got smaller, right? And the angle got smaller also, which means it's a what kind of triangle? Acute. All right? So the thing is that the signs are kind of counterintuitive to that. That's why they reverse the order to begin with. Because a squared plus b squared less than c squared is obtuse, and greater is acute, and that kind of, for some people, seems opposite. But if you think about why it's like that, like what's actually happening with the sides, it makes sense. So if this is true, if a squared plus b squared is less than c squared, then triangle ABC is an obtuse triangle. And then if a squared plus b squared is greater than c squared, then it is an acute triangle. Okay. We good? Any questions? Easy enough? All right. So then we're going to classify them, and there's two parts to this. One of the parts we already did last week or the week before or whenever that was. So step one is to tell if the side lengths can even be a triangle. So this is old stuff. Okay? Then step two is to, if so, then you classify it as acute, obtuse, or right. So there's two different things to do, and they are different things. Okay? The first one, step one, being to tell if it even is a triangle. So how do I do that? 8 plus 11. Do I just take the first two? No. I take the two smallest, which happen to be the first two. So it's 8 plus 11, and I have a blank with a question mark in it because I want to know how they're related. So this is 19 is greater than 13. So does this make a triangle? Yes. So it does, and then that means I can move on to step two. If the answer is no, then you can't classify it as acute, obtuse, or right because it's not even a triangle. Make sense? Like you don't even have to go any farther. So then step two is to figure out what happens with the Pythagorean theorem here. So again, you know that this is the biggest one, so we use that as C. So 8 squared plus 11 squared, blank with a question mark in it, 13 squared, because I need to know how this is related. 8 squared is what? 64 plus 121. And 13 squared is 169. Right, so 64 and 121, 185, and 185 is greater than 169. Okay, so that means that a squared plus b squared is greater than c squared. So what is it? Acute. This is an acute triangle. Okay? And all of that stuff is part of your answer. You can't just say acute without showing why and what you did to figure it out. We good? All right, so then over here, step 1, I'm going to take 5 plus 7 and see how is that related to 10. So what's 5 plus 7? 12. It's greater than 10, so does this make a triangle? Yes. So since this is yes, that means I can proceed to the next step. So it's going to give me 5 squared plus 7 squared, blank with a question mark, 10 squared. 5 squared is 25 plus 49, and then 10 squared is 100. So 25 and 49 is 74, and 74 is less than 100, so what kind of triangle is it? Obtuse. And if I had gotten that they were equal, what would it be? A right triangle. Good. There we go. Any questions about any of this? On the homework, you are likely going to have to find something that they didn't ask you for to find what they did ask you for on a couple of times. Okay. The other thing is this. I didn't think about it this week until it was too late, but I did not have priority day this week. And, I mean, I knew that. I didn't really think about the fact that y'all should know that, until it was too late. And then priority day for science was on Monday, which was different than it has been all year, right? That caused some people to end up with detentions because they missed their science priority day because it was just weird. Now, it is on you to make sure that you know. Should we try and help you make sure you know? Yes. And in the future, I will do what I can. I can't guarantee that anybody else is going to do that. But so in the future, if I don't have priority day or if it's a different day, I will make sure that I let you know that. So next week, there is a math priority day. It is not on Monday. Off the top of my head, I have no idea what Monday actually is. I just know it's not math. So heads up if you need to check something else. My priority day is Wednesday, but none of you are going to be invited because it's going to be a pre-cal only. I will put that in Schoology and let you know. I just wanted to also say it to you so that you're not stressed out over whether or not you're missing something. Okay, we good? All right, good deal.